All right, we skipped lesson 13. I've kind of combined it with this lesson. So this lesson is lesson 12. By the end of this lesson, you'll be able to graph an equation in standard form where one of the values in the coordinate plane pair equals 0, and you'll know you're successful when you can graph equations in standard form that represent horizontal and vertical lines. Our standard, we are continuing with standard 8EE5 about graphing proportional relationships. We're going to review some things, do some examples and exercises, close out the lesson, review what we've learned, and then you'll do your exit ticket. All right, so you see that I have done a lot of work here already, and this is just to kind of refresh you about what we did yesterday, so there's no need for you to write on the screen unless you want to take some notes. So yesterday we learned how to take a linear equation that was written in standard form, and standard form is ax plus by equals c, where these numbers a, b, and c are constants, or coefficients to variables. We learned how to choose a random value we want for x, plug it into our equation, and solve for y. So you see that I've done that for 1, 2, 3, 4 different x values so far, and I've already plotted, I've only done 3, but I've plotted those 3 points on my graph to the right, and I've shown my work off to the side as well. So I'm just going to do one more with you to review what we learned yesterday. So I'm choosing the value of -4 for my x, and from there I'm going to turn the x in my equation to a -4. So this becomes 3 times -4 plus y equals -8. I'm going to solve it off to the side. 3 times -4 plus y equals -8. Draw a line through my sign. 3 times -4 is -12. So this becomes -12 plus y equals -8. I want to get the 12 away from my y, so I add 12. I do it to both sides. Over here it cancels. I'm left with y equals -8 plus 12 is 4. So that tells me that when x is a -4, y is a +4. And I can graph that pair. So my x value tells me how many to go over. My y value tells me how many to go up. So I'm going to go over -4. So I'm going to go back 1, 2, 3, 4. And then it says to go up 4. 1, 2, 3, 4. So my line's off a little bit, but that's where I would plot this, and you could keep doing this for any values you choose. Not all of them are always going to land on the coordinate plane, but you can pretty much choose any number you want. It doesn't even have to be a whole number, and you can find a corresponding value for a coordinate pair for x and y. So this is what we did yesterday. All right, so our lesson today is going to be a lot of exploration. I'm going to do my best to save you from like tedious work, so you just kind of get the gist of what we're learning today. So we have question 1 where it says find at least 4 solutions to the linear equation 1x plus 2y equals 5. I'm not going to find 4 solutions. I'm going to find, let's do 3. I'm going to split this box so I can have 3. So what I'm going to do is I'm going to choose the number 4x, plug it in, and try to get y. So I'm going to choose the number 1. I usually just always start off with a 1. So now this becomes 1 times 1 plus 2y equals 5. So this is 1 plus 2y equals 5. I subtract 1 from both sides, and I get 2y equals 4. I divide both sides by that coefficient of 2, and I get y equals 2. So when x is a 1, y is a 2. So I'm going to plot this on my coordinate plane. I'm going to go over 1, up 2, 1, 2. And this is my first point. Okay, I'm going to do 2 more points to find this. So I'm just going to pause this video and I'm going to do the work out so that you don't have to sit through and watch me do that. All right, so you can see off to the side that I've plugged in my variable with a 2 for my x variable. And I've solved and I got y equals 1.5. So when x is a 2, y is a 1.5. So I'm going to graph this. I'm going to go over 1, 2, up 1.5. All right, and I'm going to try another value really quickly, and then I'll have 3. Okay, sorry, I had to zoom out a little bit to show my work, but I plugged in 3 for my x. And when I did all that math and solved, I got y equals 1. So when x is a 3, my y is a 1. So I'm going to plot this. I'm going to go over 1, 2, 3, 1, 2, 3, and y is at a 1. So I have 3 numbers right there. I'm going to draw my line through my side. All right, I'm done with number 1. All right, so we did number 1. Now we're going to do number 2. It says find at least 4 solutions to the graph of a linear equation 1x plus 0y equals 5. We're actually going to just do 3 again, okay? One thing I want you to notice, these equations are very similar. The only difference is that this had a 2y, so the coefficient was 2, and this has a coefficient of 0. So we're going to see what changes when our graph looks a little bit different here. Okay, so we have an interesting equation here, 1x plus 0y equals 5. All right, so we have this equation, 1x plus 0y equals 5. Now before I even plug a value in, I want to show you something. 0y, what does that actually mean? Well, that means there's nothing there. There's 0 y's there. So this is the same as saying 1x equals 5. So 1 times x equals 5. Well, if I solve for this x, if I divide by 1 by both sides, it tells me that x equals 5. What does that mean? Well, if x equals 5, if I can solve for this number, does it really matter what I plug in for y? Is x going to be 5 if I plug in a 1 for y? Let's check it out. So let's see. If I do 1x plus 0 times 1, is that going to equal 5? So if I chose 1 for my y, will it be 5? Well, this becomes 1x plus 0 equals 5. I take away my 0 from both sides, it becomes 1x equals 5. That just means x equals 5. So it worked. So if y is a 1, that works out. Well, what if y is a 2? So if I do 1x plus 0 times 2 equals 5, well, I get 1x plus nothing equals 5. 1x equals 5 again. So x equals 5 again. So that means that worked. So when x is a 5, y is a 2 as well? Kind of confusing, right? So basically what I'm seeing is that I could plug in any number for y, but my x is going to remain a 5. Okay? And that's because in my equation, 1x plus 0y is the same as saying 1x equals 5. So it's just saying x is always going to equal 5. So I'm going to go ahead and graph these pairs. So I have 5, 1 over 1, 2, 3, 4, 5 up 1. I have over 5 up 2. I have over 5 up 3. And I'm sure this would just keep going on and on and on and on. So what I've noticed here is that when I simplify this equation, it becomes 1x equals 5. And what that showed me is that my x value is always going to be 5. It doesn't matter what y value I plug in. The x is going to stay 5 no matter what, as we can see in our table and in our work. So this line is a completely vertical line, which is interesting. So we're going to come up with a rule about this later on, but I just want us to move on. We're going to kind of witness a few more things, and then we'll come back to this and we'll draw a conclusion from it. Okay, so now that we've practiced a little bit, or you've at least witnessed me show you how to graph these equations where we just have one variable equaling a number, I want you to give our try numbers 4, 5, and 6. You'll see that number 4 says graph a linear equation x equals -2. I've went ahead and turned this into standard form off to the right side. So that's the same as saying 1x plus no y's equals -2. What I want you to do is to fill out this table. Okay, choose 3 values and plot these on your coordinate grid. And then I want you to do the same for number 5. Okay, and then I want you to answer the question where it has, for number 6, where it says, what will the graph of x equals 0 look like? So take 5 minutes, work on this right now, and then we'll come back together and go over this, okay? All right, so I've gone ahead and done the first one, number 4, for you guys here. You can check your work with my work, and it doesn't really matter what values you chose For y, your x is always going to be -2 because it tells us at the beginning that x equals -2. So x is always going to be -2. It doesn't matter if you choose 1, it was still -2, or 2, or 3, or you could choose 40. Your x value is always going to be -2 because that's what our equation tells us, right? So I'm going to go ahead and graph this off to the side, and then we will go over the next one. So I'm going to go -2, 1. So I'm going to go over 1, 2, up 1, and then I have -2, 2, 1, 2, and then I have -2, 3, 1, 2, 3. So you'll notice that this whole line, it's always going to be right on this vertical line, okay? So let's look at number 5. We have x equals 3. Well, what does that mean? That means that no matter what, x is always going to be a 3. I can put any values I want for these values right here, and it's always going to be 3. I could put a 1, and it's going to be 3. I could put a 2, and it's going to be 3. I could put 3. I could put -25. I could put 0.3. I could put 2/4, right? It's always going to have an x value of 3, no matter what we put in our y value. That's because our equation tells us that, okay? I didn't even have to do any math for this because I'm starting to understand this rule. So I'm going to graph this. I'm going to go over 3. 1, 2, 3, up 1. Over 3, up 2. Over 3, up 3. So this line is going to fall right here. So what can we tell about these graphs? Well, if ever we have an equation where x equals blank, the graph is just going to be vertical. Okay, and this number, you know, whatever it equals, here it equaled -2, and it was 2 spaces back for our x, right? Here it equaled 3, and it was 3 spaces forward, and that's where our line was, okay? So this value tells us where our line is. So that's what I wanted you to get from this graph, or this page. We're going to move on, and we're going to see what it looks like when we have an equation that says y equals something. The last thing here asks us, what will the graph of x equals 0 look like? Well, it's going to be vertical, and it's going to be directly on this y-axis. Okay, my pen's not working. On y-axis. Okay, because x equals 0, so it's just going to stay right here on this line. Okay, and we're done here. All right, so looking at our next 3, number 7 says find 4 solutions to the graph of the linear equation 2x plus 1y equals 2. We're only going to do 3. And I already have the table set up. I want us to try 1, 2, and 3 for our x. Number 8 is going to have us do the same thing, but there's a little difference in our equation. This time, instead of having 2x, we have 0x. So before we do this, I want you to predict what you think this is going to look like, because before we had a 0 with our y and we a vertical line. Now that we have a 0 with our x, predict what you think that graph is going to look like. And then we're just going to plug these values in and solve. I'm going to give you about 5 minutes to start on this table to get these 3 values done and graphed, okay? All right, so this problem was actually pretty simple. So I plugged in my values. When I plugged in 1 for my x, I got 1 for my y, and I graphed that. When I plugged in 2 for my x, I got -2 for my y. When I plugged in 3 for my x, I got -4. So check your work with mine. Make sure you have graphed it. So here's all my work. You can check your work with mine just to make sure it's correct. I don't know why it just took so long for it to appear. All right, but now we're going to move on to the next question. It says find at least 3 solutions to the graph of the linear equation 0x plus 1y equals 2. So I'm going to scoot over here, and we're going to look at this equation on the right. So it says 0x plus 1y equals 2. Well, if there's 0 x's, I don't know why this is all moving. Well, if there's 0 x's, then this actually simplifies to just say 1y equals 2, because 0 x's means there's nothing there. So what that means is that y equals 2. Now I'm going to plug in a random number for x and see if y is still going to be a 2. So maybe I put in 1 for my x. So this becomes 0 times 1 plus 1y equals 2. Well, this becomes 0 plus 1y equals 2, which simplifies to 1y equals 2. So when x was a 0, y was a 2. Now I'll try, maybe let's try 1. So when x is a 1, so this is now 0 times 1 plus 1y equals 2. Well, this still simplifies to say 1y equals 2. So when x was a 1, y was still a 2. So you should start to notice the pattern just like before in the last slide. Let's just do one more. 2. When x is a 2, you will see that y still equals 2. So no matter what, our y value is going to equal 2. And that's pretty much what our equation told us, right? When we simplified it, 1y always equals 2. So let's graph these and just see what our graph looks like, see if it matches our prediction. So I'm going to go over 0, up 2, right there. I'm going to go over 1, up 2, right there. I'm going to go over 2, up 2, right there. So it looks like this line is falling right on this line. So this line is completely horizontal. And it's horizontal on this line where x is, so this is our x-axis, right? And this is our y-axis. So what it's showing me is that when we have y equals 2, we're going to have a horizontal line right here on this line that's 2 above the x-axis. Okay, so now we're going to draw some conclusions about these graphs based on what we've seen so far. All right, so we have question 10, 11, and 12, and these are all about when our equations just says y equals something. Now I want you to know that this is still written in standard form. We're just missing some pieces. So remember, standard form is ax plus by equals c. In this case, our x part, our ax, this is just a 0x plus, well, we have 1y equals -2. So this is our actual equation for number 10. And we're going to see what this looks like. We're going to graph this equation. Now, if we think back to our previous example, where we had a 0x, we found that our line was horizontal. And it was, in our previous equation, it said y equals 2, and it was 2 spaces above our x-axis. So this one says y equals -2. So I'm just going to make the prediction that my line is going to fall right here on my graph. All right? And I'm just going to prove it really quick with my work. So I'm going to plug in the number 1 for my x real quick. So this becomes 0 times 1 plus 1y equals -2. This becomes 0 plus 1y equals -2. 1y equals -2. So my y equals -2. So let's see if that point falls on the line that I predicted. Over 1, down 2. Yep, it falls right there. I'm going to try another number. Let's try 5. Let's jump a little bit. So now this becomes 0 times 5 plus 1y equals -2. This becomes 0 plus 1y equals -2. And that simplifies to 1y equals -2. So again, it's just saying my y value is a -2. So I'm going to go over 5. 1, 2, 3, 4, 5, down 2. Yep, it falls on this line. I guarantee that if I plug in any number here, my y value is going to be a -2. And you can check it if you want, but this is the rule that we're learning today, guys. So maybe I did -2. It's going to work. It's going to be a -2 y value. All right? So based on that information, I want you to make a prediction where you think this next graph is going to be. So for number 11, where's this graph going to be? Y equals 3. So take a second, highlight on your graph where you think this graph is going to, or this line is going to be graphed. All right, you should have all identified a line. So y equals 3, so this is going to be a horizontal line. And it's going to be 3 spaces above my x-axis. So here's my x-axis, so it's going to be 1, 2, 3. It's going to be right here on this line. And I know that because no matter what, my y value is going to equal 3. I could put a 1 here, so it's going to be over 1 up 3. I could put a 6 here. It's going to be over 6 up 3. 1, 2, 3, 4, 5, 6. 1, 2, 3. I could put a negative 4 here. Negative 1, 2, 3, 4. 1, 2, 3. It's always going to do this. I don't even have to check my math because I know y is always going to equal 3 no matter what I put for my x value. So the last question here says, what will the graph of y equals 0 look like? So we know it's going to be horizontal, but where's it going to be? If y equals 0, it's not going to be above or below our x-axis. It's going to fall right on the x-axis. Okay, so it's going to go right over top this axis. And so the last thing I want you to know from this page is that when an equation says, I don't know why I put an apostrophe there, says y equals something, the graph will be horizontal. It's going to be a horizontal line wherever that y tells you to start, how many spaces above or below the x-axis. All right, so we're just going to close out this lesson and review what we've done today. So first I want you to remember that ax plus by equals c. We call this standard form. Okay? And we spent the last couple of lessons learning how to figure out values for these equations and plot them on our coordinate plane. Today we learned what happens when one of these variables, whether it is a or b, is a 0. So in this case, this first one that I gave you, our y is a 0. So this problem simplifies to x equals c. Okay? And when we do this, if we were to graph this, we would find that it's going to tell us exactly what x equals. Okay? And when we find out exactly what x equals, no matter what we put for our y value, x is always going to be the same. So say it said x equals 2. Then our x will always be 2 no matter what we could put, whatever we want for our negative or for our y value, and our x is always going to be that number that they give us. Okay? These graphs will always be vertical lines. So whenever it says something like x equals blank, our line will be vertical. Okay? We also learned what it looks like when we don't have an x value. So if we got an equation like this, where there were no x's, where the coefficient for our x was a 0, this would simplify to say, okay, so many y's equals c. Okay? And we would be able to find that y equals a number. And when we find that, we know that in our table, no matter what, our y is going to stay that number. So say it said y equals 2. Then no matter what, these y values have to be a 2. We could put whatever we want here. And it will always remain a 2. Okay? And when we graph this, the line is going to be horizontal. And it's horizontal wherever it tells us this. So this one would be 2 spaces away from our x-axis. Okay? So this is what we have learned today. Please make sure you understand everything before we move into our exit ticket. All right, here's your exit ticket. You have number 1 and number 2 that you're going to do. It says for number 1, graph the linear equation ax plus by equals c, where a is 0, b is 1, and c is 1.5. I went ahead and I wrote this equation out for you. 0x plus 1y equals 1.5. And then I simplified it because when there's 0 x's, there's no x's. So this is the same as saying y equals 1.5. And I want you to graph that. Okay, you can create a table of values if you want. You don't have to. It's up to you, but I want you to graph this. Number 2, same thing, but now a equals 1, b equals 0, and c equals negative 5 over 2. So I wrote this out as 1x plus 0 y's, there's no y's, equals negative 5 over 2. This simplifies to 1x equals negative 5 over 2, or x equals negative 5 over 2. Now my suggestion to you is to turn this fraction into a decimal. It's going to be a lot easier for you to graph that, and then I want you to either just use what you know from this lesson and graph this, or you can create a table of values and graph this. It's up to you. All right? And when you're done, please complete your lesson reflection that's in Google Classroom, and make sure you're getting done any missing or makeup work.